So welcome everyone. So we are continuing friction. So I will teach you one more variety of question in friction, and then we will go to circular motion. Okay. So in friction, write down range of forces to keep a body in equilibrium. Range of forces to keep a body in equilibrium. Keep a body in equilibrium. So sometimes we come across such questions. Let's say here is a body. Here is a body. And let's say its mass is 5 kg. Let's say mu here is 0.5. Okay. Now tell me how much should be this force so that the body remains in equilibrium. How much should be this force so that the body remains in equilibrium? Acha, the body remains in equilibrium means friction should be able to counteract this force. That means this force should be less than maximum friction, है ना? यहाँ पे maximum friction निकाल लो, यहाँ पे maximum friction निकाल लो, बताओ यहाँ पे maximum friction का वैल्यू कितना होगा?
25.
Yeah, it is mu n. Mu is how much? 0.5. And how much is n? It is 50. So this is 25 Newton. Yes. So if the body has to remain in equilibrium, that means friction should be able to counteract this force. That means friction should be more, maximum value of friction should be sufficient, and this force should be less. So this force should be less than 25. That means here, if this applied force is less than, less than or in the range of 0 to 25, then the body remains in equilibrium. Or you can even tell 25. Then the body remains in equilibrium. Is this point clear to everyone?
Yes, sir.
This is when one force is acting. Now let's go to the next case. Now the next case is like this. Next case is like this. This is 5 kg. Let's say this is 60 Newton force acting. The same question, I have just changed a little bit. Let's say mu is 0.5. Okay, now here is a force F acting. So now for what value of capital F this body will remain in equilibrium? Question is, find out range of F so that body remains in equilibrium. So that body remains in equilibrium. अच्छा देखो कैसे सोचना है इसको. You think with me. So I hope all of you are able to hear me. Think. Let's say this force is also 60. If this force is also 60, see, friction will act depending on what is the net force. What the net force is trying to do. Based on that, friction will act. Friction won't act depending on individual forces. So let's say this force is 60. If this force is 60, how much will be net force? If this force also is 60, how much will be net force?
0.
0. So will friction act? Will the body move? Will the body move? No. Will friction act?
No, sir.
No, because no force trying to produce. So will the body remain in equilibrium? Yes. So if this force is 60, the body will remain in equilibrium and no friction will act. Achha, think. How much is maximum friction here? How much is maximum friction here?
25.
The 25. Achha, now think what will happen if this applied force is 59 Newton. If this applied force is 59 Newton, then what will happen? Then how much will be net force? How much will be net force?
1.
1 Newton towards left. Now friction will act. So now that net force of 1 Newton is trying to slide the body towards left. So now friction will act. So how much friction will act? So you think it like this. And I'm making a table here. I'm making a table here. So this is applied force. This is the 6 Newton force. What is net force? And how much friction will act? If you think from this point of view, then things become easy. Achha. So tell me, if this applied force is 59 Newton, then this force is 60. How much is net force?
Sir, 1.
1 Newton.
1 towards which side?
Left.
Side. Left. Achha, so how much friction will act?
Sir, 1.
1 towards right. Got it?
Right.
Will the body move?
No,
No,
sir.
sir.
No. Achha. What if this force is 50? Then how much will be the net force? It is 10 Newton. Which side?
Sir, left side.
Left side. So how much will be friction?
Sir, 10 Newton.
10 Newton.
10 Newton. Which side?
Towards right.
Right side. So will the body move? No.
Sir.
No, sir.
Getting it, na? Acha. So still go on decreasing this force. Let's say this force is now 40 Newton. How much is net force?
20.
20. Yeah. Will friction act?
Yes, sir.
Yes, sir.
How much?
Yes, sir.
Sir,
20.
20.
Towards right. Will the body move?
No,
No,
sir.
sir.
No. Acha.
No, sir.
If this is 46 Newton, how much is the net force now? How much is the net force now?
Sir, 14.
Acha, do one thing, not 46. Make it 36. Make it 36. How much is the net force now?
Sir, 24.
24.
24.
24. Acha. So will friction act? How much?
Yes, sir.
So friction will act 24. Which side? This side. So what if this force is 35 Newton? Then how much is the net force?
Sir, 25.
25. Acha, so will friction act?
Yes,
Yes, sir.
Yes, sir.
Yes. The friction will be 25. Right. Got it? See how I am starting. You see, ये 60 है ना, तो मैंने इसको 60 से चालू किया और कम करता गया. And then you see, as that force is becoming less than 60, there is a difference. The net force. And then to counteract that friction is coming to picture. समझ में आ रहा है logic? But at this point, friction reaches maximum limit. Now, if I decrease, make it 34, how much will be net force? 26. Now, how much friction can act? 25.
25.
Now, can the body remain at rest?
no, sir.
No, sir.
No, sir.
So now the body cannot remain at rest. So now the body will start moving. So you see, if you want to find the lower limit, of force F, you want to know, he is asking the range of F. Range of F means he wants one F minimum value and he wants one F maximum value, in between which the body remains at rest. So if you want to find out that F minimum value, then go on decreasing it like this. And then you reach a place where you understand now maximum friction is acting. That means if F becomes less than 35, then even friction cannot stop it. The body will move. So that's how you find F minimum. समझ में आया? If you want to find F minimum, then you have to draw the diagram like this. What is the diagram? So this is 5 kg block. You want to find F minimum. So now here F minimum is acting, and here that's 60 Newton. To find F minimum. So now the body is trying to move which side? Towards left. So friction will be acting which side? Towards right. And now the friction has reached its maximum value because now it is about to start moving. Means friction has reached maximum value. So this is the diagram. To find F minimum. So do net force equal to 0. Now the net force has become 0. If F minimum becomes smaller than this, then the body starts moving. So how much is F minimum? You see, F minimum plus 25 equal to 60. So F minimum equal to 60 minus 25. How much is that? That is 35. This is the way. This was in tabular form to make you understand. This is how we actually do in class. कितने लोगों को ये समझ में आ गया? Raise your hand. Okay. Similarly, now you start thinking the other way around. I want to find F max up to which it remains at rest, right? Now I want to find F max up to which it remains at rest. So start increasing it from 60. So start increasing it from 60. So let me go to the next page. So this is the body, 5 kg. This is the body, 5 kg. And here is the applied force F. Here is 60 Newton. Okay, so this is applied force. This is 60 Newton. And how much is the net force? Here is the net force. And how much will be friction? Let's make a table. So here tell me, if F is 60, then F net is 0, then friction is 0. Body is at rest. Achha, if F is 61, then F net is 1 towards right. So friction will be 1 towards left, isn't it?
Yes,
See
sir.
how friction is changing its direction, you see. Here you see, when F was 59, you see, net force was 1 towards left. So friction was 1 towards right. But as soon as this force became 61, now net force became towards right, the friction became towards left. So you see, friction adjusts its magnitude and direction so that the body remains at rest. Achha, are all of you comfortable with my speaking English?
Yes, sir.
Achha,
Yes, sir.
okay. So now, what if this force is 70? The net force is 10 towards right. The friction will be 10 towards left, isn't it? How much is the maximum friction here? How much is the maximum friction here? 25?
Sir, 25.
Achha, if this applied force becomes 80, then net force is 20. Then friction will be 20 towards left. Achha, if this applied force becomes 85, then net force is 25 towards right. The friction will be 25 towards left. Achha, if applied force is 86, net force is 26 towards right. Friction will be 25 towards left. From here the body will start moving. है ना, यहीं तक रेस्ट पे रहेगा. So what you see, if you go on increasing this force, then one time comes when friction reaches maximum value. After that, if you still go on increasing the force, now friction cannot increase, so the body will start moving. So when body starts to move, how much is the friction? Friction has reached its maximum value. See, the logic is whenever the body starts to move, that means friction has reached its maximum value. है ना, वो समझाने के लिए मैं टेबल कर रहा था. डायरेक्टली भी हम इसको कैलकुलेशन कर सकते थे. So to find F max, you do a free body diagram like this. That this is 5 kg, this is F max, this is 60. So which side the body is trying to slide? This side. The friction must be acting like this, and friction must have reached its maximum value, that is 25. And you do net force equal to 0. So the bodies are about to start moving. So देखो what you are getting. You are getting F max equal to 60 plus 25. That's 85. That's 85. So this is the logic. Is that clear?
Yes, sir.
Yes,
How
sir.
many of you understood? Raise your hand. How many of you understood? Raise your hand. Okay. So there is a shortcut also. But still, you remember this method. See, the shortcut is simple. It is 60 plus maximum friction and 60 minus maximum friction. See here, what is 35? It is 60 minus maximum friction, isn't it? Here, what is this F minimum? F minimum is 60 minus maximum friction, isn't it? And here you see, here what is? Here it is F max is 60 plus maximum friction. So what is the range? So you can remember it also. The range is, what is that range? That range is, ये जो भी force था ना इधर 60 था ना, उसको F naught बोल देते हैं. So it is F naught plus maximum friction. Sorry, F naught minus maximum friction and F naught plus maximum friction. Isn't it? Isn't it? Like this. But still you remember the process. So now, if you have understood it, answer my next question. Here is a body. This is 4 kg. And this is mu, let's say 0.8. Let's say here the force is 86 Newton. And here the force is F. Find range of F. Find range of F for which body remains in equilibrium. Body remains in equilibrium. Karo.
Sir,
Yes.
Yes, sir.
How much?
F minimum 54, F max 118.
F minimum is 86. Here friction's maximum value is 32. So 86 minus 32, 86 plus 32. Simple. So range will be 86 minus here friction's maximum value is mu n, that is 32. So it is 86 minus 32, comma 86 plus 32. That's the range. So how much is that? 54, comma 118. This is F min and this is F max. Can you find out friction if F is 20 Newton? Find out. If F is 20 Newton, how much will be the friction?
The 32.
Yes, if F is 20,
32.
F is 20, then net force becomes how much? Then net force becomes 86 minus 20, that is 66 towards left. So friction will be towards right. Friction will be towards right. And how much? Maximum value. But the body cannot remain at rest, right? The body cannot remain at rest. Is that clear? Chalo, if you have understood,
Yes, sir.
let's solve one more question. Let's solve one more question. This angle is 37 because its value is very simple. Cos 37, you know how much? Cos 37 is 4 by 5. Sin 37 is 3 by 5. Yaad rakho. That's why many times it's given like this. Okay. This is a 10 kg block. Here mu is 0.5. Here is F. Find range of F. Find range of F to keep the body in equilibrium. So here you see basically what's happening. Here because of this gravitational force is 100, na? This gravitational force is 100. So here is normal reaction, and this side it will be mg. How much? What will be the components of mg? This will be 37. So this will be 100 cos 37. 100 cos 37 means it will be 80, and here it will be 60, right? So it's between this F and 60, isn't it? So it's simple. यहाँ पे फ्रिक्शन का मैक्सिमम वैल्यू कितना होगा? It will be mu n. Mu is how much? Mu is 0.5. N is how much? N is how much? N is 80.
80.
So this comes out to be 40. Yeah. So now ये फोर्स का मैक्सिमम और मिनिमम वैल्यू कितना होगा? 60 minus 40 and 60 plus 40. So simple, right? So it is 20, 100. So this is the answer. If you apply less than 20, it will slide. If you apply more than 100, it will slide. If you apply anything in between 20 to 100, then the net force can be balanced by our friction. So the body will be at rest, isn't it? Achha, if you apply less than 20, in which direction it will slide?
The downward.
Downwards, yeah. If you apply more than 100, then in which direction it will slide?
Upward.
Upward.
Yeah, like that you can find it. And chalo, if you have understood this, let's solve next question. This is F. This is 4 kg. This mu is 0.5, let's say. Find range of F. Find range of F so that the body remains in equilibrium. करो. चलो, today I will teach you one more method. Let us solve every question applying the 5 steps only. Chalo. So how to think it in this way. Choose the system. Acha, 4 kg is my system. Draw free body diagram. Acha, so here is gravitational force, here is friction, here is normal reaction from wall. Achha, and the applied force F. Okay, ho gaya this much. How do I know that friction will be upward? Think, if friction doesn't act, what will happen? So if friction doesn't act, the 4 kg block will go downwards. Okay, so now friction will oppose that. That means friction must be acting upward. Achha, done. Choose the system of free body diagram. Ho gaya. Then choose coordinate axis. Achha, x and y axis. Achha, then write equation. Achha, equation. So the question is find out so that the body remains at rest. Na? So I will write down equation for the body to remain at rest. So rest leke मैं equation लिखूंगा. अच्छा, rest लेके equation लिखूंगा. तो along x direction, what will be my equation? My equation will be F equal to n. Along y direction, what will be my equation? So I am assuming body to be at rest and writing equation. Along y direction, the equation will be F will be 40. Acha. And what else we have? From the condition of friction, we have that this friction should be less than equal to maximum friction. That this friction should be less than equal to maximum friction, right? Ab isme value dal do. So how much you have got for F? You have got 40. So put that at 40, less than equal to. What is the meaning of Fs max? It's mu n. How much is mu n? Mu is 0.5. And how much is n? N is F. N is F from here. So I'm just putting the value of F here, and I'm just putting the value of n here. That's all. And then continue that equation. So 40 less than equal to F by 2. That means 80 less than equal to F. So F should be greater than equal to 80. That's the answer. F should be greater than equal to 80. So if you apply a force whose value is 80 or greater than 80, then the body remains at rest. Samjhe?
Yes, sir.
Achha. So if I apply less than F, less than 80, what will happen? If I apply F which is less than 80, now let's analyze. If I apply this force which is less than 80, then this normal action will be less than 80. Then mu n will be 0.5 into 80. That means 40, less than 40. So if this friction becomes, maximum value of friction becomes less than 40, how can it stop this 40? So it can't stop this 40. So it cannot act this 40 to stop this gravitational force. So the body will slide down. But if this force is greater than 80, then this normal action will be greater than 80. Then the maximum friction value will be greater than mu n. Sorry, maximum friction value will be mu n. The maximum friction value will be 0.5 into a value more than 80. That will be more than 40. So maximum friction value will be more than 40. So 40 is pulling it. So how much will act? 40 will act. 40 will act. So the body can remain at rest. Got the logic? For example, if I apply force 90 Newton here, how much? 90. The normal reaction will be 90. Achha, then maximum friction will be 90 into 0.5. That is 45. So maximum friction will be 45. Achha, can it stop this 40? Yes. Yes. So maximum friction will be 45. 40 Newton is pulling. So how much friction will act? 40 will act. 45 won't act. So it won't fall down. Samjhe? So the maximum friction value should be greater than this pulling force. That's the logic. Or you apply 5 steps and solve it like this. Use this extra condition. Now, here I am applying a force F. Find out range of F so that 2 kg block does not slide down. Chalo solve karo. Let me see who can solve it. Start.
So 120 Newton.
Yes, it's greater than or equal to 120 Newton. Yes. See how to solve. Either you solve it using the 5 steps I said or use logic. Chalo, first let me solve using the 5 steps what I said. Simple. So the body is doesn't slide down. That means they are moving together horizontally. So now along x direction. I hope all of you understand the steps, like choosing the system, drawing a free body diagram. All of you understand all those steps, right? So along x direction it will be net force equal to how much? 6a. Right? Along y direction, along x direction, if I take the total as system, then F will be 6a. If I take only the 2 block as the system, then here it is normal reaction, and here it is mg, and here it is friction. So if I take write down for that 2 kg block, then along x direction it will be n equal to 2a, and along y direction it will be F equal to mg. Mg is 20 here. F equal to 20. These are the equations. What else we have? Along with that, I always have the equation F less than equal to Fs max. Chalo, इसमें सारे value put करते जाओ. In this, go on putting all values. So if you go on putting all values, friction के बदले कितना डालूंगा? From here, 20. Friction max के बदले कितना डालूंगा? Mu n. N from here. How much? 2a. Right. 20 less than equal to mu is how much? 0.5 into 2. A के बदले कितना डालूंगा? From here, f by 6. तो देखो ये सॉल्व हो गया. 20 less than equal to f by 6. So 120 less than equal to f. हो गया ना सॉल्व? और अच्छा लॉजिकली मैं इसको ऐसे सॉल्व करूंगा. लॉजिकली here 20 is acting downwards, so to stop it this friction must be 20. Achha, if this friction is 20, then this normal reaction I know friction equal to mu n, so mu is 0.5, so this normal reaction should be 40. Achha, if this normal reaction is 40, then this acceleration, see I am not looking at this equation, I will start thinking from here. You see how logically I think. Here this is not falling down, that means gravitational force 20 is being managed by friction force 20. अच्छा, तो friction force is 20, तो normal reaction, friction is mu n, so if friction has to be 20, normal reaction has to be at least 40, so that you know mu n 0.5 into 40 has to be 20. अच्छा, so normal reaction has to be 40. अच्छा, if normal reaction has to be 40, अच्छा, then this block's acceleration will be 40 by 2, that is 20. अच्छा, if acceleration has to be 2, then for this complete system, if acceleration is 40, then for this complete system f has to be ma, that is 4 plus 2 6 into a, 6 into 20, that is 120. So orally I will calculate it like this logically. I will progress at it's not falling, that means upward force balancing downward force. From there I will progress up to f. How many of you understood how to solve it logically and orally? Raise your hand. This is 37 degree. Find F max up to which 2 kg block remains at rest. 2 kg block remains at rest with respect to wedge. Question Bujla? Up to that much, 2 kg block doesn't slide. That means they move together. Horizontally. It's not that remains at rest means they don't even move horizontally. No, they move horizontally. They move together. That's the meaning. 2 kg doesn't slide. So, do it. Okay. Let me tell. Dekho. Let me solve this question from this wedge frame. From this wedge frame. Or chalo, wedge frame nahi. Chalo, from let me solve this from round frame only. अच्छा, now maximum force is acting. अच्छा, maximum force is acting means इससे और थोड़ा ज्यादा लगेगा तो फिर 2 kg ब्लॉक स्लाइड हो जाएगा, है ना? यही तो मीनिंग है मैक्सिमम फोर्स. इसका क्या मतलब है कि इससे और थोड़ा ज्यादा लगेगा तो 2 kg बॉडी विल स्लाइड. अच्छा, थिंक if more than this F max force acts, the 2 kg block will slide in which direction? Upward. The 2 kg block has a tendency to slide upward. So here maximum friction will be acting in this direction, downward. Tell me how many of you could understood this free body diagram?
Sir,
how many of you could understood this free body diagram? Tell. I'm telling, if maximum force is acting here, that means now friction will be acting like this. Acha, you think it like this. आप ऐसे सोचो, you think it like this. You stand on the wedge. You stand on the wedge and see. Now, if you stand on the wedge, then see, this is how the forces are acting. Acha, if I am standing on the wedge, I am in which frame? I am in which frame? Inertial or non-inertial?
Non-inertial.
Non-inertial, because the wedge is accelerating, and if I am standing on wedge and observing, that means I am in non-inertial. That means the forces acting are mg in this direction, normal reaction in this direction, and pseudo force in this direction. Pseudo force in this direction. Samjhe? Now you think, this pseudo force. If I take this as my x direction, if I take this as my y direction, then you see the pseudo force, it is in which direction? The pseudo force, it is neither in x nor in y, but it has got two components. So the pseudo force, this is one component along this, and this is one component along this, isn't it? इस pseudo force का दो component ये और ये है, isn't it? So now that pseudo force it will try to slide the body in which direction? Upward direction? Yes or no?
Yes, sir.
Yes, sir.
So
Yes, sir.
friction will act in this direction. So friction will act in this direction. Now the body is about to slide. If this applied force is now little bit more, now the body will slide only. That means now friction has reached maximum value. So first we should understand that friction किधर लग रहा है और कितना लग रहा है. So now it's clear. This is the free body diagram. है ना? So whether you look from here or you look from ground, you know, friction का यही रहेगा. बस pseudo force एक में रहेगा, एक में नहीं रहेगा. Just to show you how I understood friction is acting downward and maximum value, I was talking from non-inertial frame. है ना? So you can erase it. You can erase it. Let's solve this question from inertial frame only. Let's solve this question from ground frame only. Just to tell you how I knew the direction of friction, I was explaining from that frame. Is that clear? So you know that friction is acting downwards. Okay. Now the gravitational force is acting this side, mg. The normal direction will act this side. This angle will be 37. Yeah. So if I am looking from ground frame, then these are the forces acting: mg acting, normal reaction acting, and friction force acting, isn't it? On 2 kg block, isn't it? mg acting, normal reaction acting, and friction acting. And what the 2 kg block is doing? The 2 kg block is moving in this direction with acceleration a. I am looking from ground. Achha. That means in horizontal direction I will write net force equal to ma. In vertical direction I will write net force equal to 0. Is that clear? I am going to write. So I have chosen the system, that is 2 kg. I have drawn the free body diagram, 3 forces, N, 20, and maximum friction. And then I am writing the equation. So along x direction, this is my x direction, this is my y direction. Along x direction, tell me what will be the equation? Along x direction, net force equal to ma. So how much is the net force along x direction? You see, it's n sine 37. M sine 37 equal to m into a. Sine 37. How much is sine 37? 3 by 5. Right? So 3n by 5 equal to 2a. This is one equation. And so along y direction, net force equal to 0. Net force equal to 0. So equation will be y direction. Oh, we made a mistake. This is wrong. This is wrong. See, look at this clearly. Along y direction, net force is, this is also 37 degree. This is also 37 degree. This. So along y direction, x direction, the forces acting are, one is n sine 37, and other is f cos 37. Together it is ma, 2 into a. So that is n sine 37, 3 by 5, n plus cos 37, 4 by 5, f. F means this is f max. F means it is mu n equal to 2a. So this comes out to be, mu is how much? 0.5. So this is 3n, this is 0.5. So 4 into 0.5, that is 2n, equal to, take this 5 that side. This is 10a. So this is 5n equal to 10a, n equal to 2a. This is one equation. How many of you understood this equation? Raise your hand. Okay. Now let me write other equations. ये x में हो गया. Now let me write equation in y. Y में equation क्या होगा? Net force equal to 0 और net force equal to ma. क्या होगा? In y, what will be the equation? Net force equal to 0 or net force equal to ma? Along y, net force equal to 0. Acha, what are the forces along y direction? One is n cos 37, n cos 37 ऊपर की तरफ, and नीचे की तरफ gravitational force 20, and friction का value कितना? sin 37. So this comes out to be cos 37, that is 4 by 5 n equal to 20 plus mu n 0.5 into n into sin 37. How much is that? 3 by 5 है ना? तो how much is that? देखो कितना है ये? 0.5. So this can be written as this is 4n by 5. Bring that this side, so that becomes 3n by 10 equal to 20. How much is this? This is 4n by 5 minus 3n by 5. How much? This is 8n by 10 minus 3n by 10. That is 5n by 10. That is n by 2. N by 2 equal to 20. So n equal to 40. है ना? How much you got? N equal to 40. So how much you got A? अब n का वैल्यू इधर डालो, तो A कितना आ गया? A आ गया कितना? 20. Are all of you okay with this? Are all of you getting A equal to 20?
Yes, sir.
Yes or no?
Sir. Yes, sir.
Now for the complete system. Question was to find F max. So for the complete system, you see the force is acting F, and the mass is 6 kg, 4 and 2 kg. Oh, wedge का mass में दिया नहीं क्या? अच्छा, wedge का mass I have to give. So let the mass of this wedge be 4 kg. So this is 6 into A, that is 20. So the answer should be 120. How many of you understood this? Raise your hand. Okay. Take it. So we have completed this friction chapter. I want to ask you, how many of you felt that this chapter is easy? Raise your hand. First, how many of you felt that this chapter is easy? Raise your hand.